Okay, here's an old worksheet that I'm going to use to go over like how to draw force diagrams from a situation. Alright, so in all of them I'm just going to draw them on the picture instead of drawing the dot. Well, I'll do the first one like we normally do. So an object lies motionless. Here's your object. There's always gravity pointing down. In this case it's on that surface, so there's a normal force pushing up, and those two should be equal. Alright, for number 2, there's always gravity pulling down. There's the normal force from the ground pushing up, and this is like that one we did in class. There's nothing over here. Yes, it's moving this way, but there's nothing over here actually pushing it, so there's no other forces. So that means that's it. So we know that these two must be the same because it's not accelerating up and down this way. And it's not accelerating this way either. Alright, for 3, object slows due to kinetic friction. So now there is a force as opposed to number 2 where there was no force here. Here there is a force. So it's going to be always gravity. There's going to be a normal force. And in this case, because the object is moving this way and slowing down, friction is going to push against the direction of motion in order to stop it. Friction always acts against the direction of motion. So there's your diagram. And again, I know these two have to be equivalent because it's on a flat surface and it's not accelerating up and down. Okay, 4, gravity straight down. Here the surface is slanted, right? So normal is always perpendicular to the surface. So my normal force is going to be this way at an angle. And here I can't say that these two are equal. You can't do that because this is at an angle. If it was pointing straight up like on flat ground, then it would work, but in this case it's not, so I can't put those equality marks. Alright, let's see if I can fit this in down here. Static friction prevents sliding, so over here I'm going to draw it off to the side. There's gravity, there's the normal force, and in this case there's got to be a force keeping it from wanting to slide down, which would be friction pushing up that way. So there's your frictional force. And again, I can't use any equivalency marks on these because I don't know that they're equivalent. If I broke this one into components, then I could do that, but you can't do that in this case. 6, an object suspended from the ceiling, so gravity, and then there's a tension in that rope. And that tension in the rope must be equal to gravity because the object is not accelerating, right? And there's only forces in that dimension. Alright, number 7, again, always gravity. There's a rope pulling this way, I'll call that rope 2. There's a rope pulling this way, I'll call that rope 1. And if I'm drawing my diagram like this, I can't put equality marks on these, so I know that each of these forces would break into some X and some Y, right? But we're just drawing the basic force diagram right now. So if I did break it down, it would look like that, and then I knew that these two would add up to this one, right? But we're just doing the basic diagram. So 8, there's gravity, there's a rope right here, so I'll call that rope 1. And then there's a rope right here. I'll call that rope 2. No equality marks because I can't say anything's exactly equal. Number 9, gravity. There's a rope right there. And then right here, perpendicular to the plane, there's a normal force. No equality marks. Number 10, there's always gravity. That should be the first one every time. Now here there's going to be 2 normal forces, one from this surface and one from this surface. So the bottom surface is going to push like that, normal 1, and then the other surface is going to push that way, normal 2. Okay, number 11, these are starting to get more like situations we would encounter. Always gravity. It's on a surface, so there's a normal force. There's an applied force right here, and then it doesn't say anywhere in here that there's no friction. So if it doesn't say there's no friction, you have to assume that there is, right? So in this case, I know that these two must be equal because it's not accelerating up and down, but I can't say for sure that these two are equal or not. So you wouldn't put the equality marks if you can't say for sure. 12, gravity pulling down. It's on a surface, so there's a normal force pulling up. There's a rope pulling right here, force of the rope, and it doesn't say it's frictionless, so it would be going forward, but friction pushes it back that way. 13, this is trying to trick you into thinking, oh look, I'm pulling down this way, so that can't be what's happening on the block. But remember, all we care about is the block right here. Nothing else. We don't care about the pulley, we don't care about what's on the other end of the rope. All you're doing is you're looking at the block. So the forces acting on the block are a tension force from the rope upwards and the weight or gravity downwards, and those two must be equal. 14, now you're pushing down over here, right? So instead of drawing an arrow over here, because this is pushing, I'm going to draw it down this way. So first, always gravity. Here's the force of the push. Here's the normal force from the surface. And then because the object would want to move this way, right, like this, then there's got to be a frictional force pushing against it, because it doesn't say that it's a frictionless surface. Alright, last four, really easy. 15, object is falling with no air resistance. There's gravity, and that's it. There's no air resistance, that means that's it, there's just gravity. 16, the object is falling at constant or terminal velocity. So here, there's going to be gravity, right? But you know that because it's falling at a constant velocity, that's the magic word, that means that the acceleration has to be 0. So there has to be an air resistance force pushing back up, and that has to be equal to gravity. 17, the ball's rising. When the ball's in the air, the only force acting on it's gravity, right? So do you see anything else touching it out here? Yes, there's a, it's moving this way, but there's no force pushing it over here. The hand is down here, let it go. But there's nothing touching it, so that's the only force, right? And then 18, the ball at the top of the trajectory, it's the same thing. It's just gravity. The whole time the ball's in the air, there was that one question on the test. It doesn't matter where it's at, right? The whole time it's in the air, the only force is the force due to gravity pulling straight down on it. Alright, hope that helps. If you still need help with it, there's another video on here from one of the other worksheets we did in class about drawing force diagrams and then taking the vectors and adding up. And it has to do with drawing diagrams too, so that might help you.